We're going to take a look at these two graphs. They're both sine graphs, and we're going to take a look at the b value and then how that affects what the period of the graph is. So the first thing I'm going to do is I want to look at the graph on the left, and I want to highlight where one cycle starts and stops. We're always going to be starting here at the origin. One full cycle of the sine graph is a hill and a valley, so it would stop right there, and you actually can't see exactly what value that's at. We'll talk about that in a little bit. So that's one full cycle. So now I could do another full cycle, picking up where that one left off, and then it looks like I have room for one more. Okay, so what we're doing here is I'm trying to figure out how many full cycles there are between 0 and 2 pi. And right here, you can't really see it anymore because I drew over it, but that's where 2 pi is. So it looks like I have 1, 2, 3 full cycles from 0 to 2 pi. And now I want to take a look at the equation. This number right here that's in between sine and x is your b value. So the fact that b equals 3 tells us that there should be 3 full cycles between 0 and 2 pi. That's not a coincidence that those two things are the same. So now if I take a look at the second graph on the right, this b value of 1/2 tells me that I should have half of a cycle between 0 and 2 pi. And if you look at this graph, it's almost a little hard to see because I don't have enough space to show you what the rest of it would look like, but this part right here is just the hill. I don't have any room to do the valley, which would kind of be like going down here. So this graph is only half of the original sine graph. Now, I want to go back and talk about what the period of each graph is, because you can't actually see what the period is on either of these graphs. So just remember that we have a formula to find the period of a graph, and that is 2 pi over your b value. So since we were given the equations, we can find the period of these graphs. So for this first one on the left, my b value is 3, so the period would be 2 pi over 3. So even though you can't see it, right here where it switches from blue to yellow, that would actually be 2 pi over 3. And what that's telling me is that the length of the blue one is 2 pi over 3. And then that's also the length of the yellow one and the length of the green one. They're all the same length, which is 2 pi over 3. The next one is a little bit harder to see because you can't really see what it is, but I do have a b value. So what I can do is I can do 2 pi over b, and this one looks complicated because I have a fraction in the denominator of another fraction. But the way that you handle this is you take the numerator and you multiply by the reciprocal of the denominator. So I took 1/2 and I flipped it upside down. 2 pi times 2 would be 4 pi, and then I don't need to write that it's over 1. It's not wrong, it's just unnecessary. So the period of this graph would be 4 pi, which kind of makes sense because if you think about it, if half of the graph stops at 2 pi, then if you did the whole thing, it should stop at 4 pi. So, and then the graph of this other one was 2 pi over 3. So there's one other thing I want to point out before I move on, and that is that if you look at your b value, if your b value is bigger than 1, your period is going to be smaller than 2 pi. So there's like an inverse relationship. The bigger the b value, the smaller the period. And then if you go to the second one, actually let me write this down. So if you have a big b value, you're going to have a small period. If you have a small b value, so like in this one, our b value was 1/2, you're going to have a big period. And by big period and small period, I mean that a small period would be less than 2 pi, and a big period would be greater than 2 pi. Let's take a look at these 4 examples. All we're doing is identifying what the period of each function is. So I want to remind you that we have a little formula to figure out the period of a graph, which is 2 pi over b. The first thing I want to do is go through and identify the b value for all of these equations. The b value is always the number that's in between sine and x. So in number 1, our b value is 8. In number 2, it's a little bit hard to see, And what I want to do is rewrite this equation in an equivalent form. You could rewrite this as 3 sine 1/5 x. So since that 5 is in the denominator, it's actually going to be a fraction for b. Number 3 is really similar. It's x over 4, so my b value is actually 1/4. And then for number 4, my b value would be this 5. So now the next thing I'm going to do is take that formula and I'm going to plug those b values in for b. So I'm going to take, for number 1, it's going to be 2 pi divided by b, which is 8. And then you have to see if you can simplify. And in this case, I can. 2 over 8 reduces to 1 over 4. So my final answer for the period of this equation would be pi over 4. You can write the 1. You could write 1 pi over 4, but it's not necessary. All right, number 2. We're going to do 2 pi over b, which is 1/5. So here I have a fraction and a fraction. So we're going to take the 2 pi and we're going to multiply by the reciprocal of 1/5. So that would be 5 over 1. And 2 pi times 5 is 10 pi. And then I don't need to write the 1. It would be unnecessary. So my period here is 10 pi. So I want to stop for a second. And I want to go back to something I said on the previous slide. I said that if you have a big B value, so 8 would be considered a big B value, like in number 1, your period should be small. So what that means is less than 2 pi. And 1/4 is definitely less than 2. So that works out. For number 2, I have a small b value. So that means the period should be bigger than 2 pi, and 10 pi is definitely bigger. So what I like about remembering this is it kind of helps you to mentally check your work. If you see that you have a big B value and your answer for the period is also big, you're going to know that something went wrong. Either your B value is wrong or you calculated the period wrong. All right, number 3, we'd have 2 pi over b, which is 1/4. So this is going to be really similar to number 2. We're going to multiply 2 pi by the reciprocal of 1/4, which is 4 over 1. 2 pi times 4 is 8 pi, and then the 1 would be an unnecessary thing to put on in the denominator. So the answer would be 8 pi. So again, small b, big period. All right, last one, number 4. I'm going to do 2 pi over the b value. And this one, I don't have a fraction, so I don't have to multiply by the reciprocal. And 2 and 5 don't reduce, so I'm actually done. I don't have to do any extra work there. These examples, we're kind of going backwards. Now we're going to take information about a graph and we're going to write the equation. The tricky thing about this is that we can't take period and plug it directly into the equation. What we put into the equation is a b value, and the b value we can get by knowing the period, but they are not the same. So I'm going to write that up here because I think that's something that gets a little tricky. So period does not equal the b value. They are related, but they're not the same. So we have an equation that we talked about previously, and that is that the period of our graph is equal to 2 pi over b. Well, now we know the period, and we want to find b. So I want this little equation that I just wrote in purple, I want it solved for b. So I'm going to show you how you can rearrange a few things to make that happen. So if I wanted to solve for b, the first thing I would do is multiply by b on both sides. So I would get b times the period equals 2 pi. And then if I wanted b by itself, I would divide both sides by the period. So my equation would end up being b is 2 pi over the period. So it's almost the same equation, this one and this one that I kind of wrote on. Almost the same equation, but b and the period are flipped. So we're going to use this one that I put the star next to. That's what we're going to use to find the b value, which then we can plug into our equation. So let's take a look here at number 1. It tells me period is 2 pi. So I'm going to use this formula with the star because I need my b value. So I'm going to do 2 pi divided by the period. The pi's cancel, and then 2 over 4 reduces to 1/2. So I'm going to plug 1/2 in for the b value, which is the number that's going to be between sine and x. So here's what my equation looks like. Y equals sine, and then I'd have 1/2 x for my b value. Number 2, there's an amplitude change, and there is a period change. So the first thing I need to do is figure out what my b value is. So we're going to use the same formula, 2 pi over b, 2 pi over the period, which is pi over 2. And now we're going to have to take that and do a little bit of work because it's a fraction in a fraction. So this is going to turn into 2 pi times the reciprocal of pi over 2, which is 2 over pi. The pi's are going to cancel out, and 2 times 2 gives me 4. So that's my b number. And again, just kind of be thinking, if you look at this, period is small, so b should be big. Okay? So you can kind of double check your work as you're going. Now this one has an amplitude of 2, so I need a 2 in front of sign, and then my b number goes after sign but before x. For number 3, I have a reflection, which means that my sign is going to be negative. I have a midline, and remember that the midline is going to be your k number. And then I have period of pi over 4. So remember, this one has a small period, so I should have a big number for b. So let's figure out what it is. So I would have 2 pi over the period, which is pi over 4. So I'm going to have to multiply 2 pi by the reciprocal. The pi's are going to cancel, and 2 times 4 is 8. So small period, big b number. All right, so now I have y equals, because it's reflected, it's going to be negative. I don't have an amplitude, so I don't need another number. And then I have my b number, sine of 8x. And then my midline number gets added at the end. All right, the last one I'm going to do here is number 4. We have to figure out the b value. So I'm going to do 2 pi over b, which is 2 pi over period, which is 2 pi over 3. So we're going to have to multiply by the reciprocal, 3 over 2 pi. What ends up happening here is that the 2 pi's cancel each other out. But what I'm going to do here, just for the sake of showing you what you would do if they didn't cancel, I'm only going to cancel out the pi's. And now what I would do is multiply straight across. So the 2 and the 3 get multiplied to make 6. And then the only number in the denominator is 2. And 6 divided by 2 is 3. So my b value is 3. What I was talking about before, if you have 2 pi times 3 over 2 pi, the 2 pi's are identical. So they actually cancel out completely, leaving you just with 3. So either way you want to simplify it is fine. So our final answer here, the only thing that's changing is period. So I'm going to have sine of 3x, because the only thing that changed was my b value. Now we're going to take a look at these graphs. We're going to identify the period, the number of cycles, and then we're going to write the equation. So there's a helpful hint. Depending on what the graph looks like, it's going to be either easier to figure out exactly what the period is, or figure out how many cycles are between 0 and 2 pi. So the first helpful hint is that if you can clearly see where one cycle stops, then that number where it stops is the period of the graph. So take a look at number 1. If I start at 0, 0, which we always will, and I go to a hill, valley, and stop, this point right here, I can see that that is one full cycle. And I actually kind of wrote over it, so you can't see it very well. But right here is actually 6 pi. So what this tells me is that the period of this graph is 6 pi. Now, that is not going to work for example 2. If I take my starting point at 0, 0, and I go up and down and come back up, this right here would be my stopping point. It is not labeled on the graph what that is. So even though it worked for number 1, I was easily able to see that the period is 6 pi for number 1. I can't do the same for number 2. So the helpful hint for situations like number 2 is to look and count to see how many cycles there are from 0 to 2 pi, because that's going to give you your b value in the equation. And then we can use that formula 2 pi over b to figure out what the period is. So let's go ahead and do that. So I'm figuring out how many cycles there are between 0 and 2 pi. So I'm just alternating between blue and yellow until I get to 2 pi, which is almost at the end of the graph there. Okay, so now I got to 2 pi. That's my stopping point. So now if I take a look here, I have 1, 2, 3, 4, 5, 6 full cycles between 0 and 2 pi. So that would be my answer for number of cycles. All right, so those are the two different ways that you can get started with these problems. Now let's go back to number 1 and actually finish it. Now, number of cycles. We kind of talked about this little makeshift formula. If you are looking for the number of cycles, what you're actually solving for is b. And we talked about how b is really 2 pi over the period. And I know that the period is 6 pi. So my b number would be 2 pi over the period, which is 6 pi. The pi's would cancel out, and then 2 over 6 reduces to 1/3. So there's a third of a cycle between 0 and 2 pi. Now the equation, the only thing that's changing is the period of this graph. The amplitude is 1, the midline is 0, it's not reflected, nothing else is going on. So my equation is just going to be sine, and then I'll put in my bx. Now for number 2, I was able to figure out the number of cycles, but I don't know what the period is. So I'm going to use this formula, where I'm going to say period is 2 pi over b, because I know that 6 is my b value. So if I did 2 pi over 6, which is my b value, and I reduced it, I would get pi over 3. So what that means is that this point right here that I'm just putting in orange, that's actually pi over 3. And it wasn't labeled on our graph, so we couldn't see it, but this is the way that you have to kind of go backwards to find it. Now as far as the equation goes, again, amplitude is 1, midline is 0, it is not reflected. The only thing that's changing is the b value, so this would be the sine of 6x. The last thing I want to mention, and I've said this a bunch of times, if you look at number 1, you have a small b value, so you have a big period. And on number 2, you have a big b value, meaning that you should have a small period. So just keep double checking. It's good to practice doing those things to get used to it, so that when you see it on a test, it's kind of second nature to check your work. Now we're going to take almost everything we've learned and smush it all together into one problem. The only thing we are not going to talk about is phase shift. We're not going to talk about period and phase shift changing together, because that gets pretty complicated. All right, so for number 1, first thing we need to identify is midline. Now this is something you may be able to see by looking at the graph. I want to show you at least one example where I show you those formulas, and I want to remind you what those are. The midline formula, remember that it's always going to be y equals, and then you're going to take your top y value plus your bottom y value and divide by 2. So for midline of number 1, our top y value is actually 0. The bottom y value is -4. So I'm going to have y equals 0 plus -4 over 2. 0 plus -4 is -4. And -4 divided by 2 is -2. So my midline would be at y equals -2, which you maybe could see without having to do all that work, and that is fine. Amplitude is another one. You may be able to see it, but there's also a formula if you can't. So let me write this down. If you want to find amplitude, this one is just a number. It doesn't have to be an equation. You're going to take the top y value minus the bottom y value and divide by 2. So for amplitude, the top value minus the bottom divided by 2. This would turn into 4 over 2, or 2. And if you looked at the graph, if you started at the green line and you went up to the top, it's 2 boxes, and then green line to the bottom is also 2 boxes, so you can kind of double check that your midline is in the right spot too. All right, now we have to look at number of cycles from 0 to 2 pi. So I'm going to start by just highlighting one cycle. Now when I look for one cycle, I'm starting at 0, and I'm starting on my midline. It's easier to see that way. So I would have to go to a hill, to a valley, and then back to 0. So that would be one cycle. And I just want to point out that that cycle ends at a point that is not labeled on our graph. So we're not going to be able to use any of our markers to find period just for this one. All right, now my next cycle starts here and ends here. And then another one from here to here, and that gets me to 2 pi. So I can see 3 full cycles from 0 to 2 pi, so I'm going to put a 3 there. Now remember that this actually is telling me my b value. So to find period, remember the little formula is 2 pi over b. So period here would be 2 pi over 3. Now my equation is the last piece of this. I'm going to have y equals. This graph is not reflected. That's always important to check. The way that I know it's not reflected is from my starting point here, my graph goes up rather than down. So it's not reflected. I don't need a negative. Amplitude is 2. That goes first. Then I do sine of b, x, and since b is 3, I put that in. And then midline is minus 2, and that goes at the end. Now for equation 2, for problem 2, I need to find my midline again. This time I'm just going to eyeball it, and I can see that it looks like right at 0 would be the midline. And when I figure out amplitude, I can kind of check to make sure that I have that right. So if I look here, amplitude is going up 1 here, and it goes down 1 here. So since I got the same number on both, I know my midline's in the right spot. Number of cycles between 0 and 2 pi. We're going to take a look here. Now I notice when I'm tracing over this graph, I notice that I go down first. So I'm going to make myself a little note down here for when I do my equation. I'm going to put a little star that this graph is reflected. And I know that because my graph was a valley and then a hill. It goes down first. So I've got one cycle highlighted. Okay, here's another cycle. Here's another cycle. And then this last one gets me to 2 pi. So I see 4 cycles between 0 and 2 pi. So I'm going to write down that this is 4, and remember that's your b value. So period would be 2 pi over b, which is 4, and that reduces to pi over 2. So what that means is, and we could have actually seen this one on the graph, this right here is where the blue, that light blue cycle stops, and you can see that it stopped right at pi over 2. So that was my period. All right, now for equation, we've got a lot of stuff going on. First of all, it is reflected, so I need a negative. Amplitude is 1, meaning I don't need a number. I can just go sine. And then b is 4. Since midline is 0, I don't need to write plus 0. I can just leave it as is. The midline of this first graph is at 3. So I'm going to draw that in. So that's my first answer here, y equals 3. Now for amplitude, this one, it's kind of strange. The highest it gets is half above the green line and half below the green line. And I know that it's half because if you look at this distance right here, it's halfway in between 3 and 4. So it goes up to 3.5 and down to 2.5. So my amplitude is 1/2, or you could write 0.5. I prefer fractions though. Now the next thing we're going to figure out is how many cycles between 0 and 2 pi. So I'm going to start highlighting some things. We're always starting when x is 0, and this graph goes up, down, and back to 0. So that would be 1 cycle. And I want to point out right now, since I can see 1 cycle, and I see exactly where it ends, if I go all the way down here to the x-axis, this right here is going to be the period of our graph. So since I can actually see the marking on the x-axis, I can figure it out. I'll actually show you too, once we figure out b, how you can do that algebraically, but sometimes it's easy to figure it out without having to do too much work. Now the second cycle would be here, and that brings us to 2 pi. So what that tells me is that there are 2 cycles from 0 to 2 pi. Back to this period thing, I know it's 2 pi over b, and then these 2's would cancel, leaving me with just the pi. So either way, you can use the formula, you can look at the graph, you should get the same answer. For this equation, I just want to point out this graph is not reflected, and I know that because that first yellow where I traced over the graph, it went up first instead of down, so I know it's not reflected. Amplitude is 1/2, that goes first, and then I do sine bx, and then midline would be plus 3. All right, last one, number 4, midline looks like it would be at 2. And I'll double check that once we figure out amplitude. So I'm going to look at, from my green line, it looks like I'm going up 2, and it looks like I'm going down 2. So since I got the same distance between the top and the bottom. I know my amplitude is 2 and that my midline is in the right spot. Now I want to trace and figure out one period of the graph. So starting here at 0, and I notice that I'm going to go down first. So I'm going to make myself a little note down here at the bottom for when I do my equation that this graph is reflected. Okay, so that was one cycle, and then if I pick up where the yellow left off, that gets me to 2 cycles. Okay, now I traced over 2 cycles, and I just looked down at the x-axis and I realized that I'm way past 2 pi. So when I'm asked for the number of cycles between 0 and 2 pi, I actually don't even need that blue one. But what I can see is if you look at where the yellow one stops, and then you go down to the x-axis, this tells me what the period of the graph is. So kind of like in number 3, I can see right now that the period of this graph is 3. I'm sorry, the period of the graph is 4 pi. Now when I want to figure out the cycles, it's hard because it's a fraction, it's not a whole number. So I think the easiest thing to do would be to use that little formula that b is 2 pi over the period. And I know that period is 4 pi. The pi's cancel each other out, and then I end up with 1/2. So there's half of a cycle between 0 and 2 pi. And that kind of makes sense if you look at your graph. If you're looking just at this part, this little valley right here, and then you stopped at 2 pi, you've got half of your graph. You've got the valley, but not the hill. So it kind of makes sense. Now this last part, the equation, remember that it's reflected, so we need a negative. Amplitude is 2. B is 1/2. And then midline is positive 2.